Hello and welcome back to another quantitative chemistry video. This one is just aimed at triple students because this is going through titration calculations and calculating the concentration of an unknown solution. This could also be aimed at A-level because the same way of working applies for A-level chemistry as well. There will be A-level chemistry videos following soon, so if anyone is going to stick with chemistry after their GCSEs, please stay tuned. There will be videos posted about A-level chemistry. So this question, they've asked me to calculate the concentration of potassium hydroxide. It's worth 6 marks. That's telling me they are probably going to ask me to do quite a lot of work for this question. The reason it's worth 6 marks is they want the concentration in 2 units, moles per decimeter cubed and grams per decimeter cubed. So let's just familiarise ourselves with the 2 equations to calculate concentration. So concentration is equal to moles divided by volume, or concentration is equal to mass divided by volume. It doesn't matter which one you choose to start with, but I'm going to focus predominantly on this one. This will make my life a little bit easier for me to be able to work out everything I've got, because they've given me moles per decimeter cubed in this one. So if you remember, the units for this one is moles per decimeter cubed, and this one is grams per decimeter cubed. So another equation we're going to need to use, because they want me to first work out moles per decimeter cubed and then grams per decimeter cubed. There are a few different ways to do this, but once I've worked out moles per decimeter cubed, if I just times it by the relative formula mass, that will give me my units in grams per decimeter cubed, because of the equation moles equals mass divided by relative formula mass. So this is what I will do as my final step. So now I've talked through what I'm going to do, I'm now going to go through exactly how I'm going to lay it out. So let me just remove all of this stuff. If I had unlimited space, I would have left it there. Unfortunately, I don't have much space on my screen. So, reading the question. The student found that 15.5 centimetres cubed of dilute sulfuric acid completely reacted with 25 centimetres cubed of potassium hydroxide. I'm hoping we've all recognised the fact that my units are not matching up. So I've got centimetres cubed and then moles per decimeter cubed. These should be the same. Both of these should be decimeters cubed, not centimetres, decimeters. So I need a way of going from centimetres cubed to decimeters cubed. You could go the other way, but because the question has asked for decimeters cubed, I would recommend doing that as your first step, save you having to convert twice. So if I've got 15.5 centimetres cubed, I have to divide it by 1,000 to get it into decimeters cubed. So 0.0155 decimeters cubed, and 25 divided by 1,000 is 0.025 decimeters cubed. These are very, very useful. These two alone will also gain you a mark. Depends on the question, you might even get a mark for each of them, but you'll definitely pick up at least 1 mark. So I'm just going to write these numbers at the top over here so we don't forget them. 0.0155 and 0.025. Like I've mentioned, if you're stuck completely on this question, start by looking at the units. Are your units how you want them? So with this table, you could do the massive table. So the massive table to work out these would be your ratio, your mass, your MR, moles, volume, concentration. Because as you go down the table, you're going to divide. But what I would suggest, because it's a titration question, you do not need all of them. You're just going to need ratio, moles, volume, concentration. So ignore the mass and MR. Yes, you will need to use the MR a little bit later on, but I'll talk through that in a minute. So when you're doing your table, top line of your table should always be your equation, because your first step should be balancing your equation. With titration, as long as you read the question carefully, they've given me the details for sulfuric acid and they've asked me to find the concentration of potassium hydroxide. Therefore, my products are pretty much useless. I don't need them. Doesn't matter what my products are, it's not going to impact it. So to save you some time, I haven't included them on here. Going to start off by doing the ratio. Ratio is 2 to 1. Fill in any information I know from the question. I've got a volume of sulfuric acid as 0.0155, a concentration of 0.5, and a volume of potassium hydroxide as 0.025. So, a bit like a reactant mass calculation, for me to be able to calculate this concentration, this question mark of potassium hydroxide, I first need to work out my moles of potassium hydroxide. And to do that, I'm going to have to work up my table, therefore I'm going to times it, which makes sense because moles equals concentration times volume. So 0.5 times 0.0155 is the same as 0.00775. Once I've got this one, I now need to move these moles over here, over to the moles of potassium hydroxide. But because it's not a 1-to-1 ratio, I need to times it by 2 divided by 1, because I've got a 2 here and a 1 here. So timesing it by 2, that will give me an answer of 0.0155. So all I've done is times that number by 2. Now to work out my concentration in moles per decimetre cubed, all I've got to do is divide. So I'm going to just get my calculator open a second. I'm going to do 0.0155 divided by 0.025, which gives me an answer as 0.62. So that then is my answer in moles per decimetre cubed. So we've done half of the question. They've asked me to do it in moles per decimetre cubed. Now I need to convert it to grams per decimetre cubed. And as mentioned right at the very start of the video, to do that, all I've got to do is times it by the MR of potassium hydroxide, which is 56. So I'm going to times this by 56, which will give me 34.72 grams per decimetre cubed. Please always, once you're finished, reread the question and make sure you've answered it correctly, and the fact you've checked that you've given the correct units and that you've given the correct significant figures or decimal place. This one has not given me how many significant figures or decimal places it's after, so I would leave it as at least 2 significant figures. So top one, 2 significant figures, bottom one is 4, but you won't lose any marks either way. I hope this has helped. As I mentioned at the start of the video, I will be posting easier versions of titration calculations, which is more just looking at the first half, so everything above the line I have just drawn. Hope this has helped. If you need any help with anything, please drop it in the comment section and I will let you know as soon as possible. Thank you very much. Have a wonderful day.